For the bubble sort algorithm, we obtain the following relation relating the number of items in the array to the number of comparisons. And this can also be written backwards. So the number of comparisons is 1 plus 2 and so on to n minus 2 and up to n minus 1. And this is now consistent with the iterative or bottom-up approach. So when n equals 1, we have 0 comparisons, and when n equals 2, we have 1 comparison, and when n equals 3, we have 1 plus 2 comparisons, and so on. And therefore Bn minus 1 is equal to 1 plus 2 up to n minus 2. And if we subtract Bn minus 1 from Bn, well, all these terms are going to cancel except n minus 1. And that gives a first order non-homogeneous recurrence relation. And we can solve this by superimposing the homogeneous solution and the particular solution. And the homogeneous solution is a constant by 1 to the power of n. So recall that Bn minus 1 is equal to 0, and therefore Bn is always equal to Bn minus 1. And 1 to the n is 1. And for the particular solution, we use the method of undetermined coefficients, which has a similar form to the function on the right. So what we have is a constant by n plus another constant. But because this constant part of the solution has the same form as that of the homogeneous equation, then we just multiply this by n. And now we can substitute this into our recurrence relation. So Bn is Cn squared plus Dn minus Bn minus 1, which is Cn minus 1 squared minus Dn minus 1. And that's the left-hand side. And if we expand this, we have Cn squared plus Dn minus Cn squared minus 2Cn and minus C minus Dn plus D. And we can cancel out some terms. So we're left with 2Cn minus C plus D. And now we equate this to the right hand side of the recurrence relation. And now equating the coefficients of n, we get 2c is equal to 1, or c is 1/2. And equating the coefficients of n to the power of 0, we have minus c plus d is minus 1. And if you substitute c is equal to 1/2, d is minus 1/2. And replacing c and d in our particular solution, we have 1/2 n squared minus 1/2 n. And then superimposing the homogeneous and particular solution, we get a plus n squared on 2 minus n on 2. And given our initial condition, b1 is equal to 0, you'd get 0 is equal to a plus a half minus a half. So that gives a is equal to 0. And we obtain the same solution as we did in the previous video using the arithmetic series. And therefore n squared on 2 minus n on 2 is on squared. So even though we had a nested loop where the number of items that get compared get reduced, the bubble sort algorithm is still on squared. Please subscribe, like and comment to help me reach more students.